Today we will discuss stationarity in time series. See, regression is a very useful tool, but if its assumptions are not taken care of, it becomes inexact and sometimes gives inappropriate results. Regression should be used very carefully. Regression analysis involving time series data, historical data, a critical assumption is that series under consideration is stationary. A time series is stationary if its mean and variances are constant over time. A stationary time series is one whose properties do not depend on the time at which the series is observed. It is free of time. Thus, time series with trends or with seasonality are not stationary. The trend and seasonality will affect the values of the time series at different times. On the other hand, a white noise series is stationary. We will discuss white noise in the coming slides. We have already discussed the issues of white noise in some other video. It does not matter when you observe it, it should look much the same at any point in time. Some cases can be confusing. A time series with cyclic behavior is stationary. This is because the cycles are not of a fixed length. Why stationarity in time series? Damodar Gujarati has written in his book Econometrics by examples why stationarity in time series is important. If a time series is non-stationary, a researcher can study its behavior only for the period under consideration. Each time series will be a particular episode, so you cannot study the time series over other time periods. You cannot generalize it. If we have two or more non-stationary time series, regression analysis for such time series will be spurious regression, as we may get high R square and high T stats, while Durbin-Watson test stats will be very less than R square, meaning that there is autocorrelation. It means estimated equation may forecast wrongly. Let us see the example. This chart is for the data for Nifty for the period 2017-18. The data is from 1st April to 31st March 2018. This data shows the trend. They are the Nifty closing prices, daily closing prices. See the data, there is a trend. It moves up from somewhere 9,000 around 9,000 to it goes to 10,000. It shows some trend, though in between it goes up and down, but there is a trend. It is not a stationary series. But if we difference the closing prices, first difference of the closing prices, and then you see the graph chart. Nifty 50, this series is stationary as it does not show any trend. This series is stationary, so this series is good for regression. This series is good for regression. Now Even if we remove the time trend, series does not become stationary. Say how we can remove the trend. This is the procedure for detrending. We will talk at the end of the slides. Say closing price is equal to constant plus B into T plus error. If we regress closing price on time, so you will get constant plus BT plus error. Now this error is your detrended series. If you see the error, because this is without time, so this E, the time series E, that will be your detrended series, that is close minus A minus BT. But this series is also not stationary. So you'll have to find out the ways how this can become stationary. When the different series is white noise. What is white noise? Yt minus 1. Present value minus past value, lagged value. So this will become Et. Et is a white noise. Error. This is, you can say, error or difference. Difference of the two. Rearranging this leads to random walk model. If we Yt is equal to Yt minus 1 plus. So we will discuss in the next video. So original value says by 0. So it is only the movement, that is the random walk, which makes this series. And that will say, you will say it is a stationary series. What is stationary series? This Et is equal to Yt minus Yt minus 1. So random walk models are widely used for non-stationary data, particularly financial and economic data. Why? Because the long periods of apparent trends up or down, they go up, they down, up, down. So there is an automatic stationarity. Sudden and unpredictable changes in the direction. The forecast from a random walk model are equal to the last observation, as future movements are unpredictable and are equally likely to be up or down. Random walk without drift. Drift means going little up or little down without drift. So we can say Yt minus 1 lag value, present value minus lag value, that is change in Y. So that will give you Ut. So Ut is basically your series which is stationary. Where delta is the first difference operator, though Yt is non-stationary, the first difference is stationary. A random walk model without drift is a stationary difference process. We may say RWM, random walk model. With drift, drift is just your constant. If you say that is a constant mean value. Random walk with drift, C is your constant. So you can say present value is on some constant mean plus past value plus your error term. You can say that is white noise. So where C is the drift parameter and is constant, random walk model can be written as Yt minus 1, that is change in Y, is equal to C plus Ut. Now what is the difference? Difference here is when there is a drift, so we are adding constant here, which is a constant mean. For RWM with drift, both mean and variances increase over time, which violates the condition of stationary time series. But we can still work on it. How? Although the RWM with the drift is a non-stationary time series, its first difference is stationary, stochastic process. RWM with drift is I1 process, whereas integrated with one order number 1, whereas its first difference is I0 process. Here C constant acts like a linear trend because each period of the level YT shifts on the average of the amount C. What is trend stationary? Now this we have already talked about difference stationary. We can difference the series, first difference, and then we can make it stationary. But if there is only trend, that is trend due to time, so those series can be detrended as I showed you in chart 3. We can remove the trend, we can regress the series on time means 1 2 3 4 5 6, whatever is there. So on time, so this will give me the error. This error term, the error series, is your estimated error series is detrended series. Sometimes if there is only trend, we can retrend the series. Detrending series is valid only if the time series has a deterministic trend where we can determine it is not stochastic. We will discuss how to test the stationarity and issues of unit root in the next session. Thanks for watching. You may submit your research work at Journal of Global Economy, rcssindia.org. Your work is evaluated by peers with double-blind methodology. You will get comments for your work. Thank you.